Here we go. We are back. We are waiting for all the speakers to join the second round table. I will advance here. So we are waiting just a few seconds. Yes. And here we go.
Are we in? So I think we're live, right? We're back.
Yes, we are.
And everybody's is connected, I think.
Yes.
Okay. Excellent. Excellent. Thank you. Thank you for this transition to Roundtable 2. So yeah, as introduced before, this second roundtable will be more technical, and we will dive deeper into the different details and the findings from the 4 projects on how to address these challenges for deployment in 5G corridors. And this is structured in a set of questions that cover the technical aspects, but also the logistics of deploying these 5G corridors. And then we will also touch upon a bit on the different business and regulatory aspects that's surrounding this. So maybe we can just dive directly into the first question, which tackles a bit on standardization and a bit on the current standards. So basically, what are the main features lacking today in 3GPP standards that could ensure low latency and low interruption times in cross-border handovers beyond neighboring countries? So we have been covering these cross-border scenarios in all different projects, and basically, I would be interested in knowing your findings on the hole, basically the gaps in today's standards. Maybe we can start with Fabimet. I think Paco is going to provide an answer here.
Yeah. Hi, good morning. Yeah, well, I will basically start describing which are the main technical challenges that we have here when we are crossing the border. The first is related to the interruption time. So normally in commercial networks, we are using the existing home route roaming mechanisms. And this is really a big problem here because it introduces an interruption time that is between 1 and 2 minutes. And as you can imagine, this is totally unfeasible to guarantee this seamless service continuity in connected and automated mobility services. So if we think about a connected autonomous vehicle that is being teleoperated, it will automatically stop when the interruption time is above 100 or 200 milliseconds. So what we've done in 5G Med and in the other ICT-53 projects is to implement and test different roaming optimization techniques that allow us to minimize the interruption time when the vehicles and the trains connected move across national borders. I will briefly explain the 3 roaming optimization techniques that we have implemented and tested so far on home route roaming. Okay, and then we will go to the latency. The first one is related to the use of equivalent PLMN IDs in the visited and home networks. This is eliminating the need for blind attachment attempts of the user equipment. So first optimization technique tested in 5G Met. Then we have also implemented and tested the N14 interface between the AMFs of both 5G cores of the 2 5G standalone networks that we have deployed in the network in Spain and France of our Mediterranean cross-border corridor. The use of this AMF allows us to minimize and reduce the registration times of the user equipment. And finally, we have also implemented and tested the radio handover between the cross-border cells. So it means that the cells across the border on the visited network have been configured as neighboring cells. All these optimization techniques are defined in the 3GPP standards. So the N14 interface was defined for roaming, and the other 2 techniques were already defined for intra-PLMN handover, and we have applied them for this inter-PLMN, but they had never been implemented and evaluated before in 5G standalone networks before the executions of these ICT-53 projects. So far in 5G Med, using these optimization techniques on the home programming, we have obtained interruption times between 100 and 170 milliseconds. In addition to this interruption time challenge that we have to face, we also have a latency issue here, because when we use home programming, as you may know, once the user equipment connects to the visited network, what happens is that the latency increases because all the data of the user equipment must be routed from the visited 5G standard network to the UPF of the home network. So to minimize latency in 5G Med, we are implementing and testing local breakout roaming, which will allow us to connect the user equipment directly to the UPF in the visited network. This will facilitate the efficient use of multi-access edge computing. As you know, local breakout roaming is also defined in the 3GPP standards, but it has not been deployed yet by operators due to its complexity in terms of signaling and offloading of all the billing procedure to the visited network. In addition, the combination of local breakout with the three roaming optimization techniques is not defined in the 3GPP standards, and this is something that we want to test and also evaluate in the last months of the 5G project.
Excellent. Thank you so much. Thank you so much, Paco. Maybe from the 5G rail part, we can also explore the gaps, basically, that you have been able to identify.
Yes, in our case, we have done the cross border in an emulated situation, so there was no geographical cross border. But the main lacks that we are working upon them in the 3GPP is the missing of enhanced interconnection and migration features. For interconnection, we mean that, for instance, for a voice call, we need to mix users from different MC systems, because we have this MCX part, and this feature is missing. Is not enough standardized today. And the other feature that was missing is the migration. So the fact that we can preserve service continuity for some critical applications for us, as it is ETCS, because for voice we can accept a certain interruption, and so the 3GPP is not very evoluted for the migration, meaning the profile of a user from one MC system to be transferred to the other neighbor MC system, and we are working upon that. For that reason, for the TCS case, we have used the two UEs solution. And in fact, we have um, created in the labs and in the field as possible situation of overlapping coverage, and defined criteria of priority of each UE. So whenever, for instance, the second PLMN network appears, in advance, the second UE is preparing to do it an MCX session, and this ensure for us the continuity, because from our analysis, it is of course, it is the local breakout that it is in our case what is needed. But at the very beginning of the project with 5GSA was not very well developed. This is one flavor we have done for the cross-border, and the other in another work package, I mean another lab and another test bed in Germany, because the two UEs were in France. We have, however, investigated the inter-PLMN handover, some parts, but we didn't, due to the lack of the 3GPP features, come to a very finalized situation for the MC part. But for the inter-PLMN handover, we have used the NG handover over IMF also, and we notice an interruption of about 150 milliseconds, which give us an idea of the transport cross-border part. But the MCX, for the reason I explained previously, were not deeply concluding in the project.
Mhm, mhm. Thank you very much. You touched upon a bit on the service continuity topic, which leads me to the next question, actually, which is what other solutions or what are the solutions that you have been exploring in your projects that in order to ensure proper service and session continuity in scenarios in which we have intermittent or low coverage areas, and this can be because of orography, this can be because of lacks of coverage of coverage holes, basically. So indeed, maybe you can we can start with actually with 5G roots here. So what are the different solutions that you have been proposing or you've been thinking in order to tackle this issue?
Yes, in the maritime sector, we are working now on using uh, the the multi-hub solution to switch the to transfer with two private networks installed in the vessels, so that traffic is transported from one vessel to the other and then to the land public network. Also providing satellite interconnectivity in case there is no uh, possibility to use multi-hub or the connection to the land. And then we have on the terrestrial, we are using the normal 5G solutions, but also with inter-parliament handover.
Mhm. Thank you. So we have the multi-hub part and we have also the satellite part, which I think is also connected a bit on the different solutions and the 5G Med project is providing. So maybe Paco, can you provide some content here?
Yes, yes. So yeah, in 5G Med we have used 5G new radio in the N77 and N78 frequency bands. So this is quite high frequency between the 3.5 and 3.7 gigahertz. To cover the rail track and also the highway that we have in this Mediterranean cross-border corridor. But in there, as you can imagine, the orography is super complex. So we are crossing the Pyrenees in both the highways and the highway and the rail track. So there's a lot of vegetation. The orography is very, very complicated, super complex. So we had some issues to really fully cover completely all the areas, and we found some small coverage holes. So one possible solution here would be to use lower frequency bands. This is one of the solutions that we had in mind, this to use, for example, sub-gigahertz frequencies, focusing on the 700 megahertz band. Maybe that could be a good solution to explore. And then another solutions that we also implemented, especially for the rail track, is to use for those remote and isolated areas that we have in the rail track, is to use satellite technology and millimeter wave radio technology operating in the 70 gigahertz bands. And this is something that we have implemented in 5G Met to provide coverage to certain areas in the rail track. So what we have is in our connected train, it is equipped with a 5G new radio, satellite, and 70 gigahertz radio access technologies. We developed a gateway that is able to choose the appropriate technology and switch to it in real time according to the quality of service that we have in each of the radio access technologies. Mhm.
Thanks, Paco. And you also touched a bit on the railway case, which naturally also leads me to ask Vasiliki on the 5G rail project on what are your contributions, what are the different solutions that you have proposed to tackle this issue from the 5G rail project.
Yes, from for our case, in fact, we are relying on the cover of our proper band and coverage, which is the RMR band of 1900, the pre N101. But when so there are lack of coverage in certain cases for this one, we accept the public MNO's band. Um, and for today, okay, for future specifications, everything is inside, even satellite, even but for today, for the first version of FRMCS, we have our proper coverage based on this specific railway band of 5G, and after is the situation with public MNOs. And of course, okay, in any case, even in the existing of the GSMR system of today, we try to have even double coverage in the railways due to the criticity and security. They are always taking care that there are no missing coverage in a way. Yeah.
Mhm, mhm,
Also, we have the possibility, if I may say, of we have some features such as bidder flexibility, so we can change between different bidders to cope with this problem of low coverage.
mhm, mhm. Thank you so much. So we are talking about deployment, cross-border scenarios, and this deals with using different public infrastructure. We are talking about railway, we are talking about roads, we're talking about maritime scenarios, which leads me to the next question, which is related to, in order to be able to have all these deployments ready, of course, within the projects, some testing needs to be done, some large-scale testing needs to be done in order to really test what are the different solutions, what are the KPIs that we have from all the different use cases. And I'm interested in knowing a bit on the logistics side, what are the main challenges that we have been facing when using these public roads and this public infrastructure in order to go there with our teams and basically set up our large-scale tests. So, and also especially how does this cross-border aspect influence these challenges, because we have to deal with two different countries, having access to infrastructure from two different countries. So can you provide some answers here? Maybe we can start with Paco from 5G Med. Or not, Paco?
Yes. Can you hear me? Yes, you can hear me. Okay. So the challenges faced, when using these public roads. The first challenge is, of course, the long time that has been required to get permits for trials and demonstrations in the highway. It may take between 8 and 12 months. The procedures are really complex, and it takes a lot of time to have everything ready and absolutely authorized to go there and do a segregation of a lane for remote driving tests and demonstrations. So this is one of the key points here. We need to somehow simplify the procedures with the road authorities. Somehow we should simplify this. Otherwise, I mean, with these long times to get permits, I mean, it really gets complex. The same applies for the installation of roadside equipment. For example, in 5G Med, we have to install some cameras to detect abnormal traffic situations in the highway for some of the use cases. And it also takes time to get these permits, maybe 6 months to get the permit for the installation. So this is a very long process. Another important challenge here is that we have to drive very long distances every time that we have to go with the team there to test and trial. I mean, it takes like 2 hours to go from the city of Barcelona, from the airport to the cross-border area. So this means that you really need to be sure that everything works, and you really need to coordinate with the whole team in each of the use cases to do the test. Everything has to be ready and prepared. And at the same time, we need to find a base camp there, or let's say headquarters that is close to the corridor, that is close to the 5G networks that we have deployed, where all the team can be there preparing, coordinating, and monitoring the testing sessions. So basically, issues related to permits and also logistics challenges. Yeah.
Yeah, indeed. Thank you so
I
much.
may add something, Yuri and
Yes.
Paco, besides the long times that Paco described for getting the permits, it's also complicated because you need to engage with different government level bodies. So going from national level to regional to local level, all different authorities, and you have to address them separately. So this really also adds a lot of complexity. And this is talking only within one country. So when you go for a cross border with two different countries, so you can imagine it's even more complex. And this should be also simplified on the European level.
Yes, indeed. So just by going in the cross-border scenario, by having two countries, it doesn't increase the complexity by two. It's really exponential, right?
Exactly.
Yes. So I think from the 5-year blueprint project, we can also have some insights on this specific topic. Correct, Eric?
That is correct, and I fully agree with the remarks already brought forward. The situation is complex. Each on both sides of the border, you have separate procedures, methods, and so on. There might be different actors involved. It's not a single road operator who is competent in this. There are also other actors that have a say in this whole story. So it makes it very complex. It would be good that we move towards a more harmonized procedure for requesting permission for doing such. That would be a good thing, and for sure for having a single point of contact in a single member state for having the request duly investigated. The other thing is we are still talking about pilots, and most often permissions are being given for a single vehicle or an individual vehicle. If you go to larger scale testing, then I assume that you are looking to more towards a fleet of vehicles. And that is something that I think for the time being is not really considered yet in all these procedures. Because when you have a fleet with certain functionalities and towards automation and so on, the interaction among these individual vehicles, but also with the other road users or other traffic users, I would say, becomes very important. And there's also the issue about insurance. For example, we had a vehicle being authorized for participating in the test on the Dutch side of the border, but it was not allowed to cross the border and to drive in the Flemish region because of the issues with the insurance. That is something that most people overlook, but you still have requirements on the use of the public roads. Uh, Completely isolated from the fact that you are dealing here with new functionalities. It's the vehicle itself also must be granted permission for crossing the border. Okay, these were our lessons, I would say.
Indeed, indeed. Thank you so much. I would like to move on to the next question for the sake of time, where I will start with 5-year routes and 5-year rail, which is when going with this cross-border testing. Right now, we are using commercial equipment in order to do this test, and it's usually that we are facing challenges when using this equipment because the standard timeline, so the evolution of the different standards and how they translate into commercial equipment usually doesn't go at the same pace. So I will be interested in knowing what are the main challenges that you have faced when using this commercial equipment for testing, and what would be your recommendations on how this can be solved. Maybe we can start with Fabi Rail, Vasiliki.
Yes, thank you. Yes, we faced a lot of problems on that because as properly the standards for FNMCs were creating in parallel with the project, we have used for our tests starting from the chipset, a chipset that was not for our band, for the RMR band. We have a tailor-made one by Qualcomm, which was an IoT, and that has been adapted to our band in a way, not completely, but allowed us to do the tests, because without this inside our TOBA, we could do nothing. For the handhelds, we have a lot used for our tests, especially the field tests, the N78 band, to have handhelds on this, which again is not our band. For the measurements, there was a big challenge that we will hope we resolve it for future projects, because the known equipments were not adapted with the KPIs yet, what is for railways. So we had to rely on applications, KPIs, and on tools and processing made by our partners, which were the providers of these KPIs, and which were the providers of these applications. So we had our proper tools for that. And this was one other problem. And for the core part also, we had to use, for instance, from Nokia, an enterprise core, which didn't have the features we need for railways. So we tried also to use workarounds to achieve our really testing conditions. So it was a combination, however, of workarounds to achieve this.
Indeed, indeed. I believe from the 5G Roots project, this is also something that is really translatable to their project. Is that correct?
Yes, I think we face similar issues. One is that the timetable of the commercial equipment providers does not fit the timetable always of the project, that the features which implanted to use come only available at the end of the project, whereas you need them in a very early stage already, so that you have to look for workarounds. Otherwise, regarding the end user equipment, of course, we have, based on our experiences, it may be challenging to find user equipment which is working in the test networks. So for this, we have to agree, all partners in the project, on a similar user equipment to be used, so which can then be once tested and applied for all the tests.
Indeed. You also touched upon a bit on, for both 5G Roots and 5G Rail, you also talked about a bit on the evolution of the different standards versus the rate of evolution of the commercial equipment. I think from 5G Blueprint, you can also agree with this and maybe highlight a bit on this, correct?
Yes, what we experienced as well is that it's not because the standard is available that the devices and the equipment is already adapted to that. That is for sure. Secondly, even if devices in some cases are indicated to be compliant, it's not always fully the case. I'm not saying it's a big hurdle, but there was quite some fine-tuning required on the devices or the settings and so on. And in most cases, the vendors or the industrial suppliers, they were cooperating in this, so that is okay. But in general terms, there is a mismatch between is the device available in the correct layout for the things you have in mind at start of the project, and that is certainly not the case.
Indeed. And finally, I think from 5G Med, this is also something that interoperability of different vendors is something that we have been experiencing, right?
Yes. This has been one of the main problems that we have faced. We experimented a lot of problems when we test the radio handover between the G0Bs of different RAN vendors. It was failing really due to incompatibility issues. So we suffered this between Sunwave and Ericsson. Now we are also suffering that between Nokia and Ericsson G0B. So we had these two different RAM vendors especially in the border. Now we are implementing this inter-PLMN handover between Nokia and Ericsson. We already got it between two Ericsson G0Bs, but now it's also another challenge that we are facing in the project. So in principle, the commercial equipment is still not fully compliant with the 3GPP release 16 that we are testing. And as Eric was explaining, yes, we are we have to do a lot of fine tuning in the equipment, and for this, the technical support of the vendors is really crucial. Then, if we talk about the 5G cores, not only the G0Bs, etc., in the 5G cores, we also have the challenge of implementing, for example, the N14 interface. And for that, we had to align our project timeline with the roadmap of our 5G core provider. In this case, is Druid. And yes, this is something that also had an impact on the work plan of 5G Met. So the 5G core provider and the RAN vendors, all of them together with the 5G Met team to provide and to test and implement all together all these roaming optimization solutions. I mean, this has been really, really a must in the project.
Yeah, indeed. Indeed. Thank you very much for these insights related to commercial equipment. I would like to go to the last question, which is related to business. I would like to start with Eric from 5G Blueprints, because he touched also a bit upon this on his presentation, which is basically what is the main business model that you would like to propose or that you tackled within the project?
Yeah, thank you. As indicated, our project focused on teleoperation, direct teleoperation. And what we see is direct teleoperation is already being used in controlled areas. For example, having a single operator remotely steering, operating several devices or vehicles or whatever, and that implies economies of scale and economies in efficiency. What we see on the longer term, I would say, that where you would export teleoperation to public roads and involving more actors and so on, what we see is that we see a clear synergy with automation in a way that we think teleoperation can help to extend the ODD of the automation in a way that the vehicles or the vessels also can be operated remotely there where automation is not yet feasible. And it happens, for example, bring a vehicle up to the highway where automation can perfectly function. That is good. And secondly, teleoperation also could provide for a fallback scenario in case automation goes for some reason is not working correctly.
Mm-hmm.
In a way that we see direct teleoperation as a requirement for freeing quickly the road and for not having the issue of first having to analyze the situation and then giving waypoints to the automated logical algorithm, I would say, that can decide for itself. So we see a clear synergy. And on the other hand, it's also so that for teleoperation, you would have high requirements on the network, on connectivity and so on, and on especially along the highway and so on. We cannot guarantee that these requirements immediately can be met. So teleoperation is not really feasible at the moment there, but automation can. So there's really, it's in balance, they can support each other. And that's the main conclusion from our work in the field of business modeling and business analysis.
Excellent. Thank you so much. I'm getting backstage messages from Margie saying that we have basically 2 minutes left. So I will like to briefly, maybe from the 5G side, to describe a bit on the neutral host model. Very, very short, quick highlight.
Mm-hmm.
And with that, we will just wrap up and conclude and say thank you to everybody for attending. And we'll see you in the next webinar. So maybe, Jose, can you just very briefly describe this neutral host?
Sure. So as we were discussing, to have 5G connectivity along all the main corridors is the most important thing to allow these services. So what we are proposing is a neutral host model where we can, so neutral host can deploy infrastructure, both passive or active infrastructure. In the passive infrastructure, the neutral host builds a tower, and this tower can accommodate several operators. And in this way, we decrease the capex because the cost is almost divided by 2. And another model is to do the same, but also the neutral host puts the radio equipment there, which is called the active model. In this case, the neutral host is managing the equipment and the operators are just paying a fee to the neutral host to manage all this radio. And this is also
I'm sorry to interrupt you, Jose, but the session will end.
Okay, yeah, and I think this is also another way to decrease the capex and the opex for operating.
Okay, thank you. Thank you very much. So yeah, we need to cut this session right now. So thank you everybody for attending. You will have the recordings on the session. Thank you for all the speakers and thank you for the insights of all 4 projects. And we will be happy to get in touch with all of you. So thank you everyone.
Thank you.
Okay.
Bye
Thank
bye.
you very much.
Thank you.
See you.
Bye bye.
Thank you. Bye.
Bye bye.